Today's lecture will look at oil pollution in the ocean and the cleanup of that pollution and the side effects of both the pollution itself and the cleanup. Now, oil can be found in pockets below the seabed, which were formed over millions of years by the breakdown, the cooking, and the pressurization of dead sea creatures and organic matter that's buried below the mud on the bottom of the ocean, and you can see that on the diagram on the left. The oil is then accessed via offshore oil drilling rigs. Again, you can see above the surface on that diagram that are spattered throughout the shallower water on the continental shelves that surround all the continents on Earth. These are but one source of oil spills, but they are the biggest source at 45%, roughly 45% of spills. Other spills that we may encounter on the ocean in large numbers are spills created through oil tanker disasters, such as the Exxon Valdez, spills caused by the general shipping and shipping accidents, as well as onshore spills, which are then released into the ocean, as well as other both miscellaneous and natural sources of oil. These spills are often very difficult to contain, control, and clean up because of the variables associated with the ocean environment and the type of oil. For instance, crude oil can be dense, like that of the crude that we'll talk about coming out of Western Canada. And in this case, much of the oil spill would actually sink to the bottom of the waterway almost immediately. Ocean variables like surface currents, strong weather systems, etc. may cause spills to spread more quickly or move in different directions at different speeds than is predicted early on, and therefore overall ocean oil spills are much less predictable than those on land. When a spill happens, there are both short and long-term effects. Naturally, the oil first spreads, then some sinks, some evaporates, and then some is broken down and taken out of the system by the sun and natural microbes in the ocean. And eventually what's left turns into these tar balls, which are much harder to break down and stay in the ocean system for years after the spill occurs. These spills obviously have a huge effect on marine plants and animals. Covering coastal ecosystems with a large layer of oil means a huge amount of damage to wetland areas that often house very ecologically sensitive plants and animals that are very difficult to clean and will take years and years to recover. Reefs, such as the Great Barrier Reef, can also sustain a huge amount of damage from spills. As far as animals, things like marine birds, the pelican on the left, whose feathers are purposed to disperse water and keep the birds warm, are ruined, and the birds often lose the ability to fly and thus lose any hunting abilities as well. They also commonly digest this oil, which can serve as a poison for their body. Similarly, things like shellfish, fish, whales, dolphins, seals, sea otters, etc. It can make life hard for them because of the covering of these animals and the need for blowholes to be open or oily skins to be able to shed water. And as well, it increases birth defects in later generations. So these oil spills have very long-term consequences. So what can be done to clean up these spills? There are an increasing number of options to look at because technology continues to advance. With each major new spill, products are put onto the market and tested to see what their abilities, advantages, and disadvantages are. There are boats which skim the oil off the water's surface to help remove the oil from the water. You can do controlled burns of the surface oil under the right conditions. You can use chemicals which break down the oil into smaller parts so that it can sink to the bottom or more further be broken down naturally. Oil may also be soaked up in absorbent materials such as hay, wood shavings, hair, all these different natural materials that we have. Or oil, once it hits land, can be cleaned up by hand, also often using shovels, brooms, tractors, etc., to scrape rocks, clean up sand, etc. When birds and other animals that have been exposed to oil are being cleaned, they are usually brought to a cleaning site where they are essentially given a bath with intensive hand washing. And this can take hours to process a single bird by multiple people. So the process of cleaning oil spills has come a long way, obviously, but is still far from perfect and far from efficient. And this will be seen in our first case study. Our first case study, which we talked about in class, was British Petroleum, BP's Deepwater Horizon disaster. And it was an offshore oil rig, and there's a huge amount of offshore oil, as mentioned earlier. The potential for ocean pollution, if there are problems on these platforms, is huge, and that was discovered in 2010 when the BP Deepwater Horizon drilling platform, which was in the Gulf of Mexico, as you can see on the image on the left, just southeast of the Mississippi Delta region of Louisiana, exploded and caused a major oil spill that lasted 87 days before it was capped, before the drill was plugged, and an estimated 4.9 million barrels of oil spilled into the Gulf. The explosion that started this spill was a result of BP not taking the advice of many contractors who worked for them when it came to building specifications and safety measures. Instead, they did the bare minimum and often skipped suggestions that would cost them any time and money in favor of getting the platform producing the product, pumping the oil. The explosion and the resulting spill obviously devastated marine life and marine ecosystems in the area. The cleanup of this spill was intensive given the focus of the press, and there were up to 40,000 different variations, solutions proposed to BP, included in this were the traditional approaches, obviously, of cleaning birds, burning and skimming surface oil, and chemical dispersants. But these methods were not always done in the traditional way. For instance, new types of boats came into the equation that hadn't been there before, and new chemical dispersants. The problem is new technology helps with the cleanup, but each advance in technology could bring potential problems as well. For instance, the use of a new powder. They had a powder that would help collect the oil together. The problem with this powder is there wasn't enough around, and it was too difficult to make it quickly to actually help with the BP oil spill, and it's too expensive to keep around in large volume. So with a spill this size, there was actually a limited ability for that powder to help with the spill. Now, there have been huge lawsuits against BP saying that the chemical dispersants they use have actually had long-term health effects on the area residents as well. They blame the dispersants for spikes in cancer and many unexplained and radical deaths. As you could see in one of the videos we watched, a guy swam in the Gulf and days later died. And they say it's from the chemical dispersants that were used in the area. Also, the chemical dispersants causing these tar balls, as you can see on the right-hand side, these tar balls continue to wash up to this day and will for years to come on the beaches in the Gulf. And many, in fact, argue that spills of this magnitude, it may be better to just let nature naturally clean up the oil rather than using all these chemical means, because in the end, they're not sure if the cleanup methods, if they're any better for the overall environment than just letting the oil spill run its course. Now, the result of the Deepwater Horizon spill was obviously devastating, but if there is a bright side to spills like these, it means that there's new money being put into research and development, new cleanup methods are being investigated, and hopefully that will help in the future stop these future disasters from having such a devastating effect. Now, lastly, I want to look at tanker spills, and we specifically talked about the Exxon Valdez spill, which occurred in 1989 off the south coast of Alaska, as you can see in the image on the left. On the right-hand image is a close-up of that area, and you can see the area of the coastline that was covered by this spill due to the ensuing winds, ocean currents, tidal effect in the area. Now, this wasn't that far off the west coast of Canada, which affects the way west coasters feel today about oil tankers in the area. Now, the Exxon Valdez was a super tanker that ran into a reef outside the shipping lane in near the Alaskan port that it was coming out of. And it was later reported basically that the accident was caused because regulations were not being followed. And this wasn't the first time. It was a common and accepted practice for oil tankers in the area to go outside the shipping lanes to avoid ice, though it was outside the actual regulations put in place. In the case of the Exxon Valdez, the captain also happened to be drunk, so there was a huge amount of human error that was blamed for the accident. And that will always be the case, that in tanker spills, there's always human judgments that are being made to steer these boats. And no matter what safety measures are put in place, humans can fail. The result left a huge environmental disaster in its wake due to the fact that A, it was in an ecologically sensitive area in the north, and being in the north meant that the natural breakdown of oil would take longer and the natural regrowth of vegetation in the area would take a lot longer. Now, the bright side of this disaster is that regulations are now increasingly strict when it comes to shipping crude around North American shores. Double-hulled tankers are being used so that if a grounding occurs, it is less likely to breach that second hull, which holds the main oil storage tanks. And adherence to shipping lanes is now extremely diligently enforced. And most times, there are multiple small boats escorting the ships in and out of the ports, and often local captains who have specific knowledge of the area take control of the tankers when entering and exiting harbors, just to give that extra level of know-how in the area. That being said, there's a great deal of fear out there still that tanker traffic could cause future oil spills in the area. And this brings us to the last bit, looking at the Northern Gateway Pipeline. The building of the Northern Gateway Pipeline is to carry oil from the center of Canada's western province, Alberta, to the BC coast, where it would then be shipped to China. It's become a hugely contentious issue, certainly for British Columbians, but for many Canadians. Much of this is because of the Exxon Valdez disaster and how it affected the mindset in the area. Obviously, the money of a port like this, of the jobs in building the port and the pipeline, would bring a huge amount of economic boom to BC and Alberta. The problem is, even though there are tight regulations to get ships in and out of the port of Kitimat, which would look like this image on the right, the argument that it only takes one mistake, one human mistake, to create huge ecological disaster. And many of the people of British Columbia believe that no amount of money is worth that exchange for the disaster that would ensue.